Hello and welcome to yet another series of tutorials. In this series, we'll be taking up LCDs and interfacing them with the Arduino Uno. We'll be using timers to perform certain interesting operations on the LCD. So LCDs are basically liquid crystal displays, and we will be using 16x2 displays, which basically means displays with 2 rows and each row has 16 characters. So why do we want to do this? So pick up an Arduino, link it up to a LCD and a power supply, and you're literally ready to fly. This means that the Arduino is now ready to be unplugged from the PC and your project is ready to be mobile. So what we're going to do is, we'll be learning to use LCDs. We will marry the LCD to timer interrupts, and using them, we'll be creating 3 interesting projects. One would be a simple counter which increments every time the timer interrupt fires. Then we will be creating a very basic model which can be used for sequential operations. So what I mean by this is, like in an assembly line, you might have a bottle moving. There might be a machine to stick a label on the bottle, one to fill it up with a liquid, and one more to screw the cap on. So these are basically 3 sequential operations, and we would be using timers to create multiple interrupts. And based on these interrupts, the value on your LCD screen would change, which is basically a proxy for carrying out a series of sequential operations. I hope I'll be setting up a model to demonstrate this at a later date. The third model that I'll be creating is a simple clock which ticks away. And I'll also try to modify it to create an alarm clock at a later date. So here are some of the key ideas that I'll be exploring in this series of videos. The first and the most important idea is a comparison of the I2C or inter-integrated circuit versus the UART or the universal asynchronous receiver transmitter versus the SPI or the serial peripheral interface. And of course, we'll be exploring some other interesting ideas like use of functions, interrupts, a nested if-else statement, and a wire library, which is basically handy in connecting to I2C devices. And the whole purpose of all this is to see how we can cut the umbilical cord or the connection between the Arduino and the PC. And this really helps you in building mobile projects. So here's our shopping list: a 9-volt adapter, a breadboard, the MB102 breadboard power supply, jumper cables, the LCD I2C display, and male-female connectors. So some links for purchasing these will be put in the description box. So here's an interesting component, the male-female connectors. So these are basically connectors which are very useful in setting the Arduino free. So basically, if you were to plug these in to the barrel jack of the Arduino, I'll just be demonstrating that. Then the Arduino can take power supply directly from the MB102 or any other circuit for power supply that you set up. So here's our useful LCD display. As you can see in this orange circle, there are a number of terminals which need to be connected. And if you turn to the back side, it's simple like this. And here you can see that there are some pins which have been soldered on. And if you need to connect this to a circuit, then here's this lovely tutorial from McWhorter. I'll post the link in the description box as well. Now, if we were to connect this conventional LCD to the Arduino, here you can see that we are using up as many as 6 ports of the Arduino. And the Arduino Uno doesn't exactly have too many input ports. And so if you were to use 6 for just running an LCD, then it leaves you with precious little to do anything else. So here's an LCD display with I2C. So at the first glance, it doesn't seem to be anything great because the number of terminals on the top is exactly the same. But when you flip it over, you realize that there's a big difference. First, there's a potentiometer which you can vary to adjust the screen contrast. If you were to look at the conventional LCD, then there's no potentiometer here, and we had to connect a potentiometer separately to be able to adjust this contrast. Then look at the output pins. The output pins are now reduced to just 4. Out of these 4, 2 are of course the VCC and ground, which would be there in any circuit. But apart from that, you have just 2 connections, one called the SDA and the other called the SCL. So this basically stands for serial data and this basically stands for serial clock, and serial data is basically connected to A4 terminal of the Arduino Uno, and SCL is connected to A5 terminal of the Arduino Uno. So your circuit is hugely simplified. We have this small jumper. If we keep this jumper connected, then the LED backlight continues to be on, and if you were to plug it out, then your LED backlight goes off. So here again, it's a very simple functionality. So here's the driver chip. It's driven by PCF8574T, and it's basically based on Hitachi's HD44780. Now these are technical details which you may not be very much bothered in. You can of course read up more about this in a data sheet or check out other blogs on the internet on this subject. So that's all for our basic information. As you can see that an LCD display with I2C seriously reduces the number of connections that you're going to make on the Arduino Uno. Thanks.